Hello everyone. I am honored to present to you our research paper titled Multilingual Toxic Comment Classification Using Bidirectional LSTM. Our paper ID is 3455 and the track is Artificial Intelligence and IoT. I am Muhammad Nazul Abdal. On behalf of my co-authors, I am presenting our paper. Let us first go to a brief introduction of our paper. This paper addresses a critical challenge in the realm of online communication and social media platforms. Our paper delves into the complex world of toxic comments and how we can harness the power of advanced deep learning techniques to create a safer and more inclusive online environment. In the digital age, where online interactions have become an integral part of our lives, the issue of toxic comments and hate speech has taken center stage. The consequences of unchecked harmful language can be profound, leading to cyberbullying, harassment, and the stifling of constructive conversation. This brings us to the heart of our research, developing an efficient and accurate method to automatically detect and classify toxic comments across multiple languages. In pursuit of addressing the challenges posed by toxic comments in multilingual online communication, our research paper has established the following objectives. Our primary objective is to design and implement a robust and accurate multilingual toxic comment classification model. This model will have the capacity to effectively detect and categorize toxic comments across various languages within diverse online platforms. After that, we aim to harness the power of BiLSTM neural network architecture. This objective seeks to capitalize on BiLSTM's capability to capture contextual information from both preceding and subsequent words. We also focus on achieving superior performance compared to existing models for toxic comment classification. Lastly, we seek to undertake a comparative analysis of our proposed model against the baseline models. This comparative objective serves to highlight the advancements and competitive edge our approach offers. For our research, we use the Jigsaw Multilingual Toxic Comment Classification dataset curated for the Jigsaw Toxic Comment Classification Challenge in 2020. This dataset encompasses a diverse range of comments in multiple languages, each labeled with toxicity scores. The dataset includes comments from a multitude of languages, reflecting the linguistic diversity prevalent in online platforms. The dataset has been annotated by human moderators to indicate varying levels of toxicity, ranging from non-toxic to highly toxic. We show the distribution of data in both the training and validation dataset in the given figure. Data preprocessing is a crucial stage in our research aimed at transforming the raw Jigsaw multilingual toxic comment classification dataset into a structured and clean corpus suitable for training our bidirectional long short-term memory model. We tokenize each comment into individual words or subword units. Tokenization enables our model to process text at a granular level, capturing the essence of language structure. To ensure consistency and reduce the dimensionality of our data, we apply stemming and lemmatization techniques. This involves converting words to their base forms, helping the model to focus on semantic content. Spatial characters, punctuation, and irrelevant symbols can introduce noise into the dataset, so we meticulously remove such elements to ensure a cleaner training dataset for our model. After that, the stop words, which are commonly occurring words with little semantic values, are removed to focus the model's attention on more meaningful content. Our research mainly focuses on text-based data. However, the dataset contains some numerical or non-textual elements. We eliminate such data to ensure the homogeneity of the training corpus. The Jigsaw dataset exhibits class imbalance where a certain toxicity level is more prevalent than the other. To prevent bias in the dataset, we perform oversampling and undersampling to ensure that each toxicity class is fairly represented. Now I will discuss the bidirectional LSTM architecture. It is a development of the long short-term memory architecture that uses past and present information to forecast sequential data. BiLSTM architecture comprises several key components like input embeddings, forward LSTM, backward LSTM, concatenation, and the final classification layer. Each captures interdependence from past and future contexts by interpreting the input sequences both forward and backward, providing a more thorough knowledge of the sequential data. The PyLSTM may efficiently capture long-term dependencies and context in both directions by merging forward and backward information. This design is especially beneficial for tasks where it is crucial to comprehend the context from both the past and the future. Two unidirectional LSTMs that process the sequence in forward and backward directions comprise the bidirectional LSTM architecture. It is possible to think of this architecture as having two different LSTM networks. One receives the tokens in their current order, while the other receives them in the opposite direction. Now I will discuss the working procedure of our proposed model. The general workflow of the proposed toxic comment classifier is illustrated in the given figure. The first step involves sending the raw text to the feature engineering stage, where preprocessing and exploratory data analysis techniques are used to obtain the preprocessed data. To construct the final features, preprocessed data is put into the tokenizer along with the embedding stage. Our last set of features will be padded in the next phase before being split into training and test datasets. After that, the classifier receives the training datasets and builds the model that categorizes toxic and non-toxic comments. The effectiveness of our model is then assessed using this classification on the test dataset. Now I will show the experimental results of our model. A summary of the classification report of the proposed model is shown in this slide. Our model has performed admirably with an accuracy of 94.21%. The precision, recall, and F1 score have all reached outstanding levels, which shows how well our suggested model performs. We also show the confusion matrix of our toxic comment classification task. We use this to assess the accuracy of the model's performance. Our confusion matrix demonstrates the model's outstanding performance with previously unseen data. Now I am showing the accuracy and loss curve of our model. In our results, we show the accuracy curve to support the model's performance on the dataset. The accuracy curve depicted in the figure illustrates the satisfactory convergence of the proposed model through the training and validation stages. Despite a few low spikes, the validation curve exhibits a steady validation accuracy over most portions of the curve. We also include the loss curve of our model in this slide. The loss curve shows the overall distribution of losses for both the training and validation stages regarding the quantity of epochs. The y-axis of the plot displays the loss function's value, while its x-axis indicates the number of iterations. The low loss values in the graph demonstrate that the model gets better at making predictions and learning from the training set. After getting the results, we evaluate the model with other architectures. We analyze to determine which method is more suitable for this classification task using the same dataset. We compare our system with two other baseline models, including the recurrent neural network and the long short-term memory. For the suggested model, the training process convergence is very high. As a result, the model can accurately predict the test data and is quick to learn. We vary the number of epochs while attempting to maintain a constant target accuracy. We have provided an overview of our findings in this slide. It shows that RNN and LSTM require more number of epochs to deliver the target accuracy, whereas BiLSTM gives better accuracy in just 15 epochs. So it can be said that our model performs better than the others. In conclusion, we can say that our research paper has introduced a novel approach to address the pervasive challenge of toxic comment classification in a multilingual context. By capturing context from both directions, our model has showcased its adaptability to linguistic diversity. Through the utilization of the BiLSTM architecture and insights from the Jigsaw multilingual toxic comment classification dataset, we have achieved several key outcomes like multilingual competence, improved performance metrics, ethical considerations, and contributions to safer online spaces. We extend our gratitude to the conference attendees for their attention and engagement. With our research paper, we aspire to inspire ongoing conversations, collaborations, and innovations that contribute to a safer and more harmonious digital environment for all. Thank you.